Hello my dear students, I am Divyam and I am welcoming you all in another video in which we are going to discuss about the aromaticity of the organic compound. Aromaticity, or if that compound is aromatic, that compound should have to follow Huckel rule if that compound is monocyclic or polycyclic benzenoid compound, and if that compound is polycyclic non-benzenoid, then that compound should follow Craig's rule. Okay, so here you must be clear that if the compound is monocyclic or polycyclic benzenoid compound, then that compound should follow Huckel rule. And if the polycyclic non-benzenoid compound is there, so that must be follow Craig's rule. But you should know that Craig's rule is not in your course, so no need to worry. You just need to understand the Huckel rule. Even the detail of aromatic and anti-aromatic and non-aromaticity is also not in the NCERT, but you should know the basic idea of it. That's why I introduced it here. And let's have a look that if you asked that what is benzenoid or what is non-benzenoid, so here is one example. Polycyclic means that having a ring greater than 1. If the one of the ring is of benzene, then that compound should known as benzenoid. And if there is no benzene ring and it's a polycyclic compound, then that compound should known as what? Non-benzenoid. Okay, here is the example of azulene and indole. You should remember this. Now, if there is introduction of, or there is a restriction of pi delocalization and this restriction may be due to introduction of sp3 carbon, or this also can be possible if there is a non-planar structure. So these two criteria, if there is, then that compound is what? Non-aromatic. Alright. And in anti-aromatic, there must be a delocalization of 4 n pi electrons. 4 n pi electron. Aromatic, there is a 4 n pi electron delocalization takes place. It means if you have a compound and you calculate the electron pair in it, that should be equal to 4 n pi electrons. But you no need to worry about all these things. You just have to focus on the Huckel rule because this is given in your NCERT. So let's have a look on the criteria which aromatic compound should follow. That aromatic compound should have high degree of stabilization. Okay, also the aromatic compound give electrophilic substitution reaction and does not give electrophilic addition reaction. Always remember that aromatic compound always gives substitution reaction and does not give electrophilic addition reaction. Addition reaction means it's do not give unsaturation test and also does not decolorize the bromine water or KMnO4 water. So as I just told you that aromatic compound only give electrophilic substitution reaction and does not give electrophilic addition reaction. So let's say this is a benzene. This is a benzene molecule and this is bromine water. If there is an addition of this bromine water And if you think that this compound should be formed, so this is very wrong thing, because what addition reaction do, it disturbs the aromaticity of the benzene. As you know, benzene is an aromatic compound, and there is a change in the aromaticity, that this double bond is converting into the single bond. So this is a wrong thing, that you should know that there is no addition reaction is possible in benzene ring, or means if you will see that there is a disturbance in aromaticity of that compound, so definitely that reaction does not takes place. But if so, this substitution does not disturb the aromaticity of the benzene, and also change in the planarity of the change in the planarity of the molecule also. So definitely substitution reaction can take place in the benzene ring, but the addition reaction does not take place in the case of benzene ring. So here what both are showing, this is addition reaction product, and this is what so this will take place, the substitution takes place in the benzene ring, because there is first no change in the aromaticity of the molecule, and also the planarity is same. But in the case of addition reaction, there is a change in the, or you can say the disturbance of the aromaticity is taking place, and also the planarity is get disturbed of the benzene ring, because you can see here that this compound is no more planar in nature, but this even after the substitution reaction, the planarity is maintained of the benzene ring. So what all other criteria for the aromaticity is that there should be presence of diamagnetic, and also each carbon must be sp2 or sp hybridized, no involvement of sp3 should be there. Also the system must be cyclic, conjugate and planar. Planar, conjugation and cyclic, these three criteria should also be fulfilled, and also the aromatic compound should follow what? Huckel rule. So now let's have a look at how you can count this 4n+2 pi delocalization of electron. So let's say you have this system, this is a benzene molecule, and you have to calculate the pi electron involvement. So if you calculate, this must be what? 2 delocalized electron for this bond, to 2, 4 and 6. So how much pi electrons are delocalizing here? 6 pi electron. And if you apply 4n+2 pi rule, so just put a hit and trial method we will do, that if we put n is equals to what? 0. So if we put n is equals to 0, this comes out to be 2 pi electron. If we put n is equals to 1 here, if we put 1 here, then this will come out to be what? 4 into 1 plus 2. So this will comes out to be 6 pi electron. So you can see here that this system is also having 6 pi electron, and we can also get 6 pi electron system by applying this Huckel rule. So this compound is what? This compound is aromatic in nature. Again, lone pair is also involved in the delocalization of the bond. Okay, so we need to count this electron also, these lone pairs also. So how much should be there? 2, 4, 6. Again 6 pi electron is coming out to be there. So this is also calculated by the Huckel rule. The same is here. So this is also an aromatic. This is also aromatic. Let's count it here, that if the delocalization will create here, so this positive charge is delocalizing in the ring and the bond is shifting accordingly. So here also the system will be what? 2, 4, 6, 6 pi electron system. So again this compound is also what? Aromatic, because according to the Huckel also there 6 pi electron is what? An aromatic compound. And also take care one thing in your mind, that the compound should be cyclic, conjugate and planar. Okay, so first of all you need to learn these things, that some compounds are planar, some compounds are non-planar, because you can't get the answer by just seeing the compound. You need to know about the structure also. Okay, so here this is what? This is naphthalene, and let's count the pi electrons involved in it. This is also a conjugate structure. So 2, 4, 6, 8 and 10. So here it's come out to be 10 pi electron. So let's calculate according to the Huckel rule. So if we put, I had already put here what? 1. So if I put n is equals to 2 here, so what will come out to be 4 into 2 plus 2 pi electron. So 4 2s are 8 and plus 2 is equals to 10 pi electron. So here also you can see that this compound is also aromatic in nature. So I think it must be clear that how you are going to calculate the aromaticity of the compound. Question is there in your NCERT, that why these given compounds are non-aromatic in nature. You have to answer that why these compounds 1, 2 and 3, these 3 are non-aromatic in nature. So first of all you need to remember that non-aromatic compounds are those in which there must be the restriction of pi delocalization, and if there is restriction of pi delocalization, then there must be the involvement of sp3 carbon, or that compound is non-planar in nature. Of pi electron, that there, because there is the involvement of this sp3 carbon. So these pi electrons cannot move in the ring. So this is what? This is non-aromatic in nature. Same is happening here also. There is an involvement of what? sp3 carbon, and there is restriction of delocalization. In this compound, you need to know that this is a non-planar compound, and the real structure of this compound is like this. Okay, 1, 2, 3 and 4. This is the bond, and you can see here the pi orbital which is involved in the formation of these double bonds are not in a plane. They are somewhat like this. So they are not in the plane, and they do not allow the pi delocalization. That's why this compound is also non-aromatic in nature. So I hope you can now able to categorize the organic compound according to their aromaticity, non-aromaticity or anti-aromaticity, and you also have an answer that why some compounds are aromatic and some compounds are non-aromatic in nature. So I hope you like this video. Thank you so much for joining me.